The space between two square flat parallel plates is filled with oil. Each side, the plate is 670 mm. The thickness of the oil film is 10 mm. The upper plate, which moves at 2 meters per second, requires a force of 100 Newton to maintain the speed. Determine the dynamic viscosity of the oil and kinematic viscosity. So here, the space between square flat parallel plates is filled with oil. So this space filled with oil, and each side is equals to given length of each side is equals to 670 mm. Okay, and thickness of the oil film is denoted by dy is equals to, so here 10 mm, given 10 mm. Okay, now, and the remaining data is which moves at 2 meters per second. Here this plate, upper plate, moves at 2 meters per second, and also we given a force of 100 Newton is applied to maintain the speed. So 100 Newton force is applied to maintain the force. So at last we have to find dynamic viscosity and kinematic viscosity. Okay, so first of all we need dynamic viscosity. Okay, from dynamic viscosity we can calculate kinematic viscosity. So how do we get dynamic viscosity? So according to Newton's law of viscosity, shear stress tau is equal to mu into du by dy. Okay, so here du is equal to final velocity minus initial velocity. So initial velocity how much? 2 meter. Final velocity is 2 meter per second. Initial velocity is 0. Initial velocity of the plate is 0. So du is equals to, you will get 2 meters per second. Du is equals to 2 meters per second. Next, here dy is equal to how much? Dy is equals to 10 mm. 10 mm, millimeters. We know that 1 millimeter is equals to 10 to the power of minus 3 meters. 10 to the power of minus 3 meters. Now 10 mm is 1 mm equal to 10 to the power of minus 3 meters. Now 10 mm is equal to dy is equals to 10 into 10 to the power of minus 3 meters. 10 into 10 to the power of minus 3 meters. Okay, next, tau. What is tau? Here tau means shear stress. Tau means shear stress. Shear stress is equal to shear force by area. So here shear force is F is equals to, given 100 newtons, and shear area, so area of the plate, so they are square plates. Here given square plates. So for in case of square plates, area equal to side into side. So each side is 670 mm. Each side is 670 mm. Okay, now so area formula side into side, because it's a square plate. Okay, now side how much given? Side is equals to 670 mm. We know that 670 mm is equal to 670 into 10 to the power of minus 3 meters. You will get 0.67 meters. Now area is equals to 0.67 into 0.67. So how much? If you calculate, you will get around 0.4489 meters square. So this much area of the plate. Now we have all values. Now find dynamic viscosity. So from this formula, mu is equals to tau by du by dy. Okay, so tau means here tau means what? Shear stress. Okay, so first let us find this shear stress tau. Okay, so tau is equal to F by A. So F is equal to 100 newtons by area 0.4489. Now 100 by 0.4489. If you calculate, you will get around 222.77 Newton per meter square. Okay. Now we got shear stress. Okay. Let us substitute shear stress here. Tau value 322.77 by du means change in velocity. Change in velocity how much? 2 by dy, thickness of oil film, 10 into 10 to the power of minus 3. Now mu is equals to 322.77. Take reciprocal in denominator. You will get 10 into 10 to the power of minus 3 divided by 2. So if you calculate, you will get the dynamic viscosity as 1.1138 Pascal second or Newton second per meter square. Pascal second or Newton meter per second square. Okay, so this is first question answer. Of course, still we need to find kinematic viscosity. So how do you get kinematic viscosity? Say, we know that kinematic viscosity nu is equals to dynamic viscosity per unit density. Okay, so before that, let us assume specific gravity of oil is equals to 0.95. Now density is equal to what? Density of oil is equals to specific gravity into density of standard fluid. Density of standard fluid 1000. So 0.95 into 1000, 950 kg per meter cube. Okay. Now kinematic viscosity is equal to, okay, now dynamic viscosity 1.1138 by density 950 kg per meter cube. So if you find the value of this, you will get 1.17 into 10 to the power of minus 3 meter square per second. Therefore kinematic viscosity of the given oil is 1.17 into 10 to the power minus 3 meter square per second. These two are the final answers. Okay.